Okay, so today we're going to be talking about angles, arcs, and sectors as they relate to circles. So, first of all, an arc is basically, a section of the circle. Anything that's a curved line is technically an arc, right? Now, when we talk about arcs, they're basically extensions of the central angle, right? So if I'm talking about this angle, then I'd be talking about this arc, and they would be the same when we're talking about degrees. Obviously, there's a reason that I talked about radians early in the year, because radians are the more exact measurement of arcs, which you will see on this worksheet as well. So we'll talk about that in a second. But basically, this starts out by just naming the arcs or the angles, right? So if I'm talking about the name of an arc, I usually write the arc as like 2 letters with like a curved line on top, something like that. So this one wants me to name the arc made by the given angle. So the given angle is WQV. So this one right here is what it wants me to find the arc of. Well, we basically just look at the endpoints of that angle, which are W and V, and that's going to be the arc. So this arc is WV, a little line above it, like that, right? Now, there's 2 types of arcs when we're talking about angles. There's the normal arc, which is what this is, but if asked for the major arc, we're talking about basically everything but that arc. Okay, so that would be like WUV, like the entire rest of the circle there would be the major arc. Okay, so if it asks for a major arc, it's wanting you to go everything else that isn't included in that angle. Okay, then the next section here is wanting me to figure out measurement of the arc or angle indicated. And again, angle and the arc are basically equivalent. So on problem number 1 here, it wants me to find the measure of angle UYX. UYX. So this angle right here. Well, it gives me the arcs that go with them. So again, the arcs and the central angles are equivalent. So that means that this angle is 55 and this angle is 62, right? So if I add them together, 55 plus 62 is going to give me 117 degrees. So that's equal to 117 degrees. Okay, not too tough, right? Let's try another one. This one wants me to find the measure of arc EG. EG is this one right here, but I need to figure out what arc FG is first. So in the instructions it says assume the lines which appear to be diameters are actual diameters. Well, DG appears to be a diameter, which means it's cutting that circle exactly in half. So this half of the circle has to be 180 degrees. This half of the circle has to be 180 degrees. With that knowledge, I should be able to figure out what FG is, right? So I would just take 180 and take away 61 and 45. So 180 minus 61 minus 45 is 74. So that has to be 74 degrees, which means EG would be those 2 angles added together. So add 61 back in, and you find the angle arc EG is 135 degrees. Okay, so again, not too bad. Let's look on the next page. So this page gives me or wants me to solve for x. So again, you're using the same idea. So the central angle is the same as the arc that's opposite it, right? So on this one, I know the central angle is 45. I know the arc is 9x. They have to be the same. So 45 has to equal 9x. And then you would solve by dividing by 9. And x is going to equal 5. Okay? Let's look at another one. So this one tells me 105 and x plus 75 are on the same side of the diameter, which means they both need to add up to 180, right? So if I do 180 minus 105 minus 75, I should get what x is equal to, right? Well, if I do that, 180 minus 105 is 75. minus 75 is going to be 0. X is equal to 0. That was a tough one. Very, very tough. Okay, the next one, this is where we're going to probably spend most of the time here. So this one wants me to find the actual length of the arcs. To do this, I need to know what the degree is in radians. Now, to convert to radians, it's pretty simple. It's just the angle, so we'll call it theta, times pi over 180. Now, why is that how you convert pi or radians? Well, it comes down to basically looking at the ratio from pi to in radians to degrees. So remember, radians is just how far your radius goes around the circle, right? Your diameter goes around the circle 3.14 blah 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 times. It goes around pi times, right? That's why it's pi. Pi is the ratio of the diameter to the outside of the circle. Well, radians are half that length, right? So if I wrap my radius around the circle, it would go around 2 pi times. But if it goes around just pi, that would be half a circle, right? So pi and 180 degrees are the same measurement. So we set them up as a ratio, and then you can convert this to radians. So basically you're taking out the degree part when you convert it. So to set this up, I need to figure out what this is as a radian first. So 135, I want to figure out this arc length, because that's the bolded arc length here. So I'm going to convert 135 to radians first. So it'll be 135 times pi over 180. Well, 135 times pi over 180 is 3 pi over 4. So this can be written as 3 pi over 4. Now to figure out the arc length, you take the degree, the angle in radians, and times it by the length of the radius. So I'm going to take 3 pi over 4 and times it by 9, because that's the length of my radius. And I get 27 pi over 4. I want you guys to write that as one answer, and then the instructions say to also round that to the nearest tenth. So break that down to a decimal, and it's 21.2. Okay? Approximately. And that's what you're doing to find the length. Let's try another one just to make sure we got it. So let's try this one. 240 degrees. So again, I'm going to start by doing 240 times pi over 180. So on my calculator, 240 times pi over 180 is 4 pi over 3. So this angle can be written as 4 pi over 3. And then to figure out what that is as the measurement of the arc, I need to multiply that by the actual length of the radius, which is 11. So times 11, and I get 44 pi over 3. So 44 pi over 3 is one answer, and then rounded to the nearest tenth is 46.1. 46.1. Okay, and that is what you're doing to find the measurement of the arc. Okay, now the next thing we're going to do is we're going to find the area of a sector. So these little triangle, little wedges here, right? That would be a sector. Now, there is a formula that goes with it. Now, remember, this is not a triangle, so you can't use the 1/2 base times height or anything like that. What you have to do is you got to kind of incorporate it into the circle. So, the formula to find the area of a sector is 1/2 theta, so the measurement of your angle in radians. So you got to convert that to radians, times your radius squared. Okay, so remember radius, so you can't see that. Remember the area of a circle is pi r squared, right? So it's kind of similar there. We're just taking out the pi, replacing it with the degree in radians, which still has pi in it, and then halving it as well. So let's look at an example. So let's try doing number 17 here. So first thing I'm going to do is I'm going to convert this 60 degrees into radians. So 60 times pi over 180. So 60 times pi over 180 is pi over 3. That was one of the things on the unit circle, right? Hopefully you remember that. So to set up my formula here, it would be 1/2 pi over 3 times the radius, which is 12, squared. So let's try doing this. So 1/2 times pi over 3 is pi over 6, and then we're going to times that by 12 squared, which is 24 pi. So the measurement of this sector is 24 pi, and that's the more exact answer, right? And then if I want to get that to the nearest tenth again, fraction decimal, 75.4. And that's what you do to find the area of a sector. Again, 1/2 degree in radian times radius squared. And that's it.